I'm Tejaswini Kaktikar, and I'm a research fellow at the Maritime Research Centre and a BSc Anthropology student at University College London. And today I want to begin by clarifying my intent with this presentation, particularly given the expertise in this room, that this is not an attempt to introduce a new conceptual vocabulary for the sake of novelty, nor is it a critique of existing hydrological or policy work on the Brahmaputra. On the contrary, I found that the river is one of the most extensively studied systems in South Asia and has a rich literature on things like flood and channel migration and infrastructure development. What I hope to do instead is isolate a persistent structural gap that appears repeatedly across scientific, policy, and diplomatic domains, that being that the most influential processes shaping risk and instability in the Brahmaputra basin occur below the waterline, while governance systems remain primarily oriented towards surface domain indicators. This observation has emerged consistently across my work at the Maritime Research Centre, and my argument today is that adapting the underwater domain awareness framework to this river system is not a conceptual leap, but a necessary correction to a long-standing imbalance between what we model, what we observe, and what we govern. So the Brahmaputra is governed as a surface river, but it is shaped below the surface. This is not meant rhetorically, but causally. Across the basin, governance frameworks prioritize variables like flood stages and discharge peaks and visibly damaged infrastructure. These are all institutionally legible, legally actionable, and politically salient. They are also the variables maybe most easily communicated to disaster authorities and to the public. And so, in that sense, surface indicators are not irrational choices, but understandable ones. But many of the outcomes that ultimately matter most, things like embankment collapse or riverbank erosion, navigation disruption, or fishery decline, are all driven by sediment routing, riverbed adjustment, and scour, all of which evolve beneath the flow. To draw on a study from Assam, post-event investigations of embankment failures frequently show that the immediate trigger is not overtopping, but progressive toe scour, and that scour develops incrementally over multiple monsoon cycles well before any visible distress appears at the surface. By the time the issue is detected through conventional monitoring, the causal process has already played out. This sort of distinction between surface signals and subsurface causality is not unique to the Brahmaputra, but the consequences are unusually severe in this basin. In rivers with maybe lower sediment loads or more stable channels, surface indicators are often adequate proxies for risk, where stage discharge relationships hold reasonably well and channels adjust slowly and infrastructure lifetimes are longer. The Brahmaputra, however, behaves differently. It is a system where bed mobility and not discharge alone govern stability, and channel capacity can change within seasons, and sediment pulses move faster than our institutions. When our governance frameworks rely solely on surface indicators in a system like this, they are not just incomplete, but structurally misaligned to how the river actually behaves. And this is why many interventions appear to fail suddenly, when in reality they've been failing slowly and out of sight. This sort of governance process gap has always existed, but four contemporary pressures have made it all the more consequential. The first, of course, being accelerated infrastructure development in the basin, with upstream hydropower projects in the Tibetan Plateau, expanding navigation corridors under India's National Waterway 2, and new river terminals and embankments downstream have all significantly increased the number of fixed assets exposed to morphological instability. Each structure not only introduces risk at its own site, but also perturbs sediment and flow conditions upstream and downstream, often in ways that we only ever partially anticipate. The second, of course, is transboundary asymmetry. The Brahmaputra, as we know, is shared by China, India, and Bangladesh, but access to data, particularly relating to things like sediment retention or reservoir operation or riverbed response, remains uneven even today. This asymmetry amplifies uncertainty, even in the absence of malicious intent, so to speak. The third, of course, is climate volatility, with recent basin scale studies documenting increasing variability in monsoon intensity and sequencing, alongside glacial and cryospheric changes in the upper basin. What I think is important here is not just more floods, but also less predictable coupling between discharge, sediment mobilization, and channel response. The fourth, and this is of course particularly important in this basin, that sediment regimes in the Brahmaputra are highly mobile and poorly monitored. Take, for example, reach-scale geomorphological studies around Majuli Island, for example, have documented rapid braid bar migration, delayed planform response to discharge peaks. And all of these processes are extensively modeled in the literature, but rarely ever observed in real time. And as a result, our governance decisions are often made using representations of the river that are technically quite sophisticated, but temporally out of date. This sort of brings us to then a structural mismatch at the heart of river governance. On one side are the domains that governance manages relatively well: flood stages and extents, embankments, navigation channels, dams, and barrages. These are all visible, measurable, and institutionally tractable. But on the other side are then the processes that are driving risk: sediment regimes, rapid channel adjustments, scour and deposition, and underwater habitats. Take, for example, in the middle reaches of the basin around Assam, where embankments have been repeatedly raised and strengthened and extended over the last 2 decades. But at the same time, erosion rates along certain reaches have accelerated rather than declined. The studies show that this is not because embankments are universally ineffective, but because their interaction with sediment dynamics is poorly observed. In several cases, embankments constrained lateral channel movement and increased flow concentration and accelerated bed scour. These changes were not visible in flood stage data, but they fundamentally altered near bank hydraulics. This creates then sort of a problem. If the investments intended to reduce risk appear to increase it, not because the intervention is irrational, but then because the underlying process is not being monitored correctly. It is a fundamental structural limitation of surface-oriented governance, which is why I then described the Brahmaputra River as an invisible river. Not because it's unknown, but because some of its most influential components remain weakly observed. The river is sediment dominated. Its beds migrate continuously. Its underwater ecological structure, including things like deep pools and spawning grounds, play a central role in fisheries and biodiversity. Yet these components are observed intermittently, modeled extensively, and rarely ever monitored in real time. This creates a paradox of sorts. We have high confidence in long-term averages, but low confidence in the near-term system state. Fisheries here provide a useful illustration where declines in fish stocks are often attributed primarily to overfishing or pollution. However, both ecological studies and community narratives have indicated that habitat loss due to sediment infilling of deep pools is also a major driver. Without this subsurface visibility, however, our management response focuses on regulating catches solely rather than also restoring habitat structure. This invisibility of the underwater domain thus sort of shapes both diagnosis and policy choice, and our blindness, for the lack of a better word, has predictable consequences for governance. Surface-focused governance systems tend to share three similar characteristics. First, that they detect failure after subsurface change has already occurred. Second, that they respond to damage rather than precursors. And the third being that they reinforce reactive intervention cycles. This pattern is visible not only in flood management, but also in navigation planning and infrastructure maintenance, where dredging and repair are often triggered by crisis rather than trend. I think it's very important to stress that this reactive pattern is not just a matter of poor planning. River governance institutions are typically designed around event-based triggers: a flood threshold or a breach or a declared disaster, and budgets and legal authority and political attention are all activated by visible events. Subsurface change however, does not trigger these mechanisms. There's no institutional equivalent of an early warning system for progressive scour or sedimentary organization. And so, as a result, even when the technical expertise exists, it struggles to translate into action because the governance system is not designed to respond to slow, invisible change. The underlying issue here is then temporal, where subsurface processes are evolving continuously, but governance is reacting episodically. This sort of temporal mismatch then explains why flood management, for example, remains largely post hoc despite decades of investment. And in transboundary rivers, particularly like the Brahmaputra, this mismatch also becomes a diplomatic problem. Transboundary rivers fail where change is visible but not entirely verifiable. Downstream impacts like floods or erosion or altered sediment loads are experienced directly while upstream processes remain opaque. Critically, like sediment dynamics and channel morphology and infrastructure condition all remain largely unshared across borders today. And what this means in practice is that uncertainty itself becomes politicized, that in that vacuum, worst case assumptions fill the gap, and concerns about upstream dams become securitized not only because of scale, but also because independent verification is weak. This is then less a failure of diplomacy rather than a failure of evidence. And this is where the underwater domain awareness framework becomes analytically useful. The UDA's core principle, which is the integration of multiple observational layers to understand the system state, is entirely consistent with what may be required in the Brahmaputra today. Applied to river systems, the UDA involves systematically incorporating subsurface variables like bathymetry and sediment flux and scour patterns and acoustic ecological indicators into existing monitoring and decision frameworks. It's important to note that this is not about importing surveillance logic, but about addressing a documented observational imbalance. We already model sediment and morphology extensively. The UDA strengthens the empirical basis of those models and connects them more directly to governance. Then the implications of this sort of shift are practical. The first, of course, being that things like early detection of scour at foundations allows for targeted reinforcement before failure, particularly for things like bridges and embankments in braided reaches. The second being that dynamic bathymetry inputs improve flood forecasting by updating assumptions about channel capacity and conveyance. The third being that sediment informed infrastructure planning reduces things like maladaptive dredging and poorly sited terminals. And the fourth being that the direct observability of submerged habitats supports fishery management and livelihoods by linking ecological outcomes to physical processes. But beyond risk management, the UDA also has strategic value. By producing a sort of shared, verifiable evidence base, the UDA functions also as a trust infrastructure. It doesn't require complete total political consensus, but agreement on measurement. This is particularly relevant to the Brahmaputra Basin, where basin wide treaties still remain politically sensitive. Shared observations can stabilize dialogue even in periods of diplomatic strain. In this sense, the UDA supports hydroverification and not hydrohegemony. Many transboundary water disputes persist not because states disagree on principles, but because many disagree on the system state, on questions like what is the sediment load, where is the channel adjusting, what is changing, and what is not. And in the absence of shared observation, political narratives tend to harden, and technical uncertainty is read as strategic ambiguity. What the UDA then offers here is not agreement, but bounded disagreement, where states can disagree on interpretation while still operating from a shared evidentiary baseline, which lowers escalation risk without requiring total political convergence. Technology, however, is not the only thing that the UDA allows for. It allows for integrating historical flood memory and community river intelligence along with scientific monitoring. Indigenous communities have long tracked subsurface change indirectly. For example, among the missing tribe, flood adapted housing, cropping cycles, and fishing practices have all encoded sediment and flow knowledge accumulated over generations. Taken together with scientific monitoring, this improves both interpretation, legitimacy, and applicability. It is important, however, to note that this is not an alternative epistemology, but rather a complementary one. And that taken together, it allows our database to be richer and, well, more informed. The strategic implications then for the UDA imply three major governance shifts. The first is a shift from surface control to subsurface awareness. This does not mean abandoning flood stage management or visible infrastructure, but it means recognizing that in a sediment dominated river like the Brahmaputra, surface indicators are often lagging signals. Subsurface awareness changes when interventions become possible. Instead of responding after erosion or scour or habitat loss becomes visible, governance can then respond to precursors and to trends rather than events. Importantly, it's not a call for perfect knowledge, but for a better alignment between dominant processes and dominant indicators. The second shift is from crisis response to anticipatory governance. Much of river governance today, like I discussed earlier, is structurally reactive, where budgets and legal authority and attention are all triggered by declared floods or breaches or disasters. What subsurface observability offers here is not prediction in the deterministic sense, but anticipation and the ability to recognize when risk is accumulating, even if no crisis has occurred yet. This is a subtle but important distinction that anticipatory governance does not eliminate uncertainty entirely, but it manages it earlier and allows us and governance frameworks to manage it earlier. The third shift is from hydrohegemony to hydroverification. In transboundary contexts, power asymmetries are real and persistent. What often escalates tension, however, is not power itself, but unverifiable change. That hydroverification doesn't resolve political disagreement, but it changes the informational environment in which disagreement occurs. That shared comparable observation allows for states to contest interpretations without contesting facts. At this point, I think it's also important to note that the application of the UDA doesn't come without its concerns. One concern, of course, is feasibility and whether continuous and systematic subsurface monitoring is realistic in a river as dynamic as the Brahmaputra. The answer I would say to that is that this framework doesn't depend on an entire continuous basin-wide coverage, but on strategic observation at selected nodes, especially in this river, that are calibrated to governance needs rather than total scientific completeness. Another concern is, of course, institutional overload and whether already stretched river agencies can absorb additional data streams. And while that risk is very real, it's important that the UDA should not be understood as adding information indiscriminately, but as reprioritizing which information is crucial for decision making. A third concern is, of course, securitization, and that framing subsurface observation as domain awareness could militarize river governance. And in that sense, this risk is only there if the framework is implemented without clear ownership, clear civilian ownership, and transparency. And in the way that I've described it here today, the UDA is an explicitly a verification-oriented approach and not surveillance architecture. Finally, it's important to say what this framework does not do. It does not eliminate floods, and it does not resolve transboundary disputes, and it does not replace political negotiation. What it does allow us to do is narrow the gap between how the river behaves and how it is governed. And in a system that is as dynamic and politically sensitive as the Brahmaputra, that narrowing alone is consequential. The question then no longer remains technical. We do possess the tools to observe sediment and map bathymetry and integrate data streams. The question is whether governance systems are willing to incorporate processes that have always existed but remained largely unseen. And in the Brahmaputra basin, making the underwater domain visible is not just an academic exercise, but a precondition for resilience, cooperation, and long-term stability. Thank you.